Section 1.3. So the first thing I want to do is draw a special kind of line, and we'll mark some segments on that line. All right, so here's my line. Here's some points, some special points on this line. So what's our special line here? What kind of line is this? It's a number line. And if I mark some points on here to make a segment, so there's point A and there's point B. How long is segment AB or segment BA? 5 units. And how do we come up with 5? 3 plus 2? Or so we can figure out how far it is between them that way. What's the easy way to explain? Take the distance to 0. The way I think about it, and I think that you guys are talking about the same way, just count the spaces, right? 1, 2, 3, 4, 5, right? The distance to 0 here is 2, and the distance to 0 here is 3, and you're saying add them together. If we had really big numbers, so let's say this was negative 385, and this was positive 296, how would we figure out the lengths then? And what would you would add? How would you add them? So let's say this was negative 385 and this was positive 282. Okay, so we would add. So it's kind of like you said, how far to 0. So what were you going to say? Make it positive because our length is always positive, right? So if so we know that our length is always positive. We're talking about counting the spaces between the segments. So the length of a segment is the distance between the endpoints. And if our number's not laid, or our segment's not laid out nicely on a number line, we'll talk a little later in the chapter how we find the length of the segment. We write BA for, and I'm going to say BA for the length of segment BA. So we just leave off the bar. So BA without the bar over the top means the length of that segment. The other way we could write it is, and I'm going to say, I'm just going to put a little space here and move this over. Or we write the measure, little m, BA for the length. So the two letters with the endpoints without a bar over it, or the little m in front of the segment. M means measure. Either of these ways tell us that we're looking for the length of the segment. And the length is how far it is between the endpoints. That's all we're looking at. If we're on the number line, we can count spaces. If we have big numbers, we can figure out how far each one is from 0. We want to make sure our lengths are positive. Okay, questions on this? This makes sense. hopefully. All right. Now we want to talk about how we combine lengths. But before we do that, we want to come up with this idea. What do we mean when we say two things are congruent? Someone said something that sounded like it made sense. Same. So in everyday language, we say they're the same. For a segment, what would have to be the same? The length, same length. So congruent in general means the same. We're going to make it a little more precise, and we're going to say exactly the same size and shape. So that's what we're going to mean by congruent for now. We'll make that even a little more precise later. So congruent means the same. And we're going to say that means exactly the same size and shape. For segments, we say that they're congruent if they have the same length. So that's our first postulate about segments. We call it the segment congruence postulate. Postulate means something that we accept as true without proof. We can't prove that segments are congruent if they have the same length, but it makes sense. There's really no other way to look at it. So we're going to accept that as true. The segment congruent postulates say congruent segments have the same length. So that's what our postulate tells us. Our symbol for congruent is an equal sign with a little squiggle. So if we write something like this, this says segment AD is congruent to segment CB. So that's how we write things that are congruent. And what the segment congruence postulate says is if segment AD is congruent to segment CB, then the length of AD equals the length of CB. That's what the segment congruence postulate tells us. And it works in both directions. If the lengths are equal, then the segments are congruent. If the segments are congruent, then the lengths are equal. That's what it tells us. So makes sense? That's why we accept it as true without proof. On figures, on pictures that we draw, we show that things are congruent with tick marks. So I'm going to draw a picture here, and we'll mark congruent segments on my picture. So if we say these two sides are congruent, we would put the same number of tick marks on both sides. If we say these two sides of this triangle are congruent, I would put the same number of tick marks there. Now I put one tick mark on these because I'm not saying that these two are congruent to those two. And then I would put, if I'm saying these, the short ones are congruent, I'm going to put 3 tick marks on there. So what I'm saying is these two sides are congruent, these two segments are congruent, and these two segments are congruent. So the tick marks tell us which ones have the same length, which ones are congruent. Yes? The number of tick marks doesn't matter. look at for the ones with the same number of tick marks. So this one has 3, and this one has 3, so that tells me they're congruent. This one has 2, and this one has 2, that tells me they're congruent. So we're just comparing the ones with the same number of tick marks. 3 tick marks doesn't mean it's bigger, it's just the way we're keeping track. Okay? All right, any other questions? This is how we show congruence on figures. All right, so we're going to, now we know when segments are congruent, how we tell if they're congruent, talk about how we find their length. Now we want to know how we combine lengths. So our next postulate is called the segment addition postulate. It sounds kind of complicated, it's really not that complicated. So we're going to say if, all right guys, the phone needs to go away, please. Not just in your pocket, away. If point R is between point P and Q, on a line, then PR plus RQ equals PQ. So let's draw a picture because this might not make sense the way we wrote it, but once we draw a picture it should make sense. Here's point P. Here's point Q. Here's point R. This distance is PR. This distance is PQ, sorry, RQ. This whole distance is PQ. So what the segment addition postulate is telling us is I can take the lengths of 2 smaller segments, add them together, and I get the length of the whole big segment. I take the length of this small segment, add it to the length of this small segment, and I get the length of that whole segment. In pictures, or visually, here's one segment, I take the length of this segment, here's another segment, I take the length of that segment, the length of the 2 together is just the 2 lengths added together. That's all the segment addition postulate tells us to do. Take one length, another length, put them together, add them. That's all we're doing. Putting 2 smaller pieces together to make a bigger piece. So if we knew, for example, let's pretend that these aren't exactly the same length. Let's say this is 7 and this is 13. Together, how long would they be? 20. Okay? That's what the segment addition postulate is telling us. If together these are 15 units, and we know that this one is 7, how long does this one have to be? 7 and what makes 15? 8. That's all the segment addition postulate is telling us. I take the 2 smaller pieces, put them together, and I get the longer length. Now, of course, in math, we would like to make things with symbols and make things a little more interesting. So let's do a more interesting problem with the segment addition postulate. And really quickly, let's just say, we're not really adding segments, we're adding lengths. So it should be, technically we should say segment length addition postulate because we add lengths. All right, so let's do a couple of problems. Example, here is my segment. So I have 2 points and I have another point between them. And let's say this is L, M, and N for our points. Let's say the whole segment is 32 units. This piece is 3x plus 8, and this piece is 2x plus 4. And the problem says find LM and LN. So we have 2 segments. We have a point between. So what were you going to say, Avery? X equals 4. So you figured it out already. So let's let everybody else catch up to you. That's good. That's good. So you were you able to guess and check, or just kind of did it just pop out at you?
I just did it now.
You did it in your head. That's good. So for those of us that can't do it in our heads, including me, let's talk about how we would set this up. So the segment addition postulate, what does it tell us to do with these 2 small pieces? Add them together. This small piece is 3x plus 8. We're going to add it to this other small piece, 2x plus 4, and it has to equal what? 32, the whole thing together. We're adding the 2 smaller pieces, it has to equal the length of the whole thing together. Well, we know how to do this, don't we? What do we do here? Combine like terms. So 3x and 2x gives us 5x, 8 and 4 gives us 12, and we get 32. Now we're like the mathematician who set the dumpster on fire. We turn this into a problem we already know how to solve. So we're really happy about that. So what do we do now? Subtract 12. 5x equals 20. Divide by 5. And just like Avery said, x equals 4. All right, now I'm done, right? No? We have to plug in 4. It doesn't say find x. It says find LM and find LN. So LM equals, I'm going to plug this in here, 3 times 4 plus 8 equals, 3 times 4 is 12 and 8 is 20. And Ln had better come out to what? 12. 2 times 4 plus 4, 2 times 4 is 8, plus 4 is 12. We add those 2 together and we get 32, and we were able to check that we did everything right. If these 2 didn't add up to 32, we know we would have done something wrong. So the segment addition postulate tells us add the 2 smaller pieces and it has to equal the big piece, the whole thing together. Let's look at this problem but set up in a slightly different way and talk about what we would do in that case. Any questions on this before we move on? Yes?
The second one actually be MN instead of LN?
Oh, yes. Did I say? Oh, did we? We already know Ln, don't we? Ln is 32. So we found Mn. Thank you. So this should be Mn. All right. So let's look at this one set up in a slightly different way. So let's say this one is set up like so. And we wanted to find the same thing, find Lm and Ln this time. This time we would want to find Ln. How would we set this one up differently? We don't necessarily need to go through the whole thing. Well, what are our two small pieces this time? What's this small piece? 3x plus 8. What's this small piece? 20. What do we do with the small pieces? Add them, plus 20. And that equals what? 5x plus 12, the whole thing together. So this is how we would set this one up. Add the two smaller pieces, and they have to equal the whole thing together. Segment addition postulate, that's always how we're going to set those up. Add the two small pieces, and they have to equal the whole thing together. Yes? And then from here, we don't necessarily need to go through the whole problem. From here, how do we, let's describe the procedure. What do we do? We still combine like terms, right? So we could subtract 3x from both sides. We add these two together. So we go through the same process. Combine like terms, get x by itself. Same process, same idea. Our dumpster's on fire. We've turned it into a problem we already know how to solve. So we're happy. So I'm not going to go through the whole thing here. We've just set it up, but we know how to solve it from here, hopefully. Okay, we good? All right. And then I'm just going to say solve for x, and then plug x in. That's how we would finish, just like we did the last one. And this turns out to be the exact same problem, except this time this comes out to be 12, and the whole thing comes out to be 12. All right, one last thing to talk about today. Midpoint. What do you think we mean by midpoint? What do the words tell us? The middle, the point in the middle. That's what the midpoint is, the point in the middle. Just to make it a little more technical, we're going to say a little more precise, midpoint divides a segment into, so if our point is in the middle, let's draw a picture here real quickly, because I think we know the answer here. Here's my segment. Here's my midpoint. It's a point in the middle. So what do we know about these two segments on either side of the midpoint? They're equal distance. They're the same. So we're going to call them into congruent segments. The midpoint divides a segment into congruent segments. So if we wanted to mark this, we would put marks like that to show that those two are congruent. Yes?
Can you say into two congruent segments? Because technically you can split it up into a lot of pieces. But
Okay, we can say two. Two congruent segments. Being a little more precise. It's a good thing. Into two congruent segments. So that works. What would be the everyday way of saying it's a point in the middle, it divides it into two congruent segments? The midpoint divides the segment in half. Perfect. We have a fancy word for divides in half. We say the segment is bisected. So bisect means to cut in half. The midpoint bisects the segment. And lots of things can bisect things. It could be bisected by a line. We could have a line that goes right through the middle. It could be bisected by another segment. So It could be bisected by a plane. So our segment can be bisected by lots of different shapes. We say the segment is bisected, and we call the midpoint the segment bisector. So if we had a line that divided the segment in half, the line would be the segment bisector. It would cut the segment in half. So it just more vocabulary that we're going to use. Instead of saying cut in half, we say bisect. We call the thing that cuts it in half the bisector. So our midpoint divides a segment into two congruent segments. So we're going to set up a problem that has to do with midpoint. The two segments are the same. Yes. So let's look at an example involving midpoints. So here's my segment. And I'm going to call this R, S, and T this time. And this is 7x minus 3 and 3x plus 1. And S is the midpoint. We want to find RS, ST, and RT. So it says S is the midpoint. The midpoint does what to our segment? Divides it in half. So what do we know about these two pieces? They equal each other. For midpoint problems, the two pieces equal each other. So I'm going to say 7x minus 3 equals 3x plus 1. The two are the same. They're equal. Bisected, so the two parts are the same. And now we know how to solve this problem. I'm going to subtract 3x from both sides. So we get 4x minus 3 equals 1. This one turns out to be really nice. Plus 3, so 4x equals 4. And x equals 1. And we're done, right? Got to plug it in. Yes, Carol. Sure. No, this you could have. This is just the way I chose to do it. You could solve it a different. So what would you want to do first? So with the midpoint problem, we can't add the two because we would have to add them. This plus this has to equal something. So we have to have an equals in there somewhere. So for midpoint, the equal sign comes because the two are the same. If they're the same, they have to be equal. So for midpoint problems, you're going to set the two pieces equal. For segment addition problems, you're going to add the two smaller pieces and they have to equal the whole thing together. Okay? All right, so we have to substitute this back in. So RS equals 7 times 1 minus 3, which is 4. ST had better equal what here? If this is the midpoint. ST had better equal 4 also. So I'm going to say 3 times 1 plus 1 equals 4. They're both the same, so we did the problem correctly. And then RT, the whole segment together, how do we find that? Add the two. 4 plus 4 equals 8. And what postulate tells us I can add the two smaller pieces and get the bigger piece? Segments. And we're adding them. The lengths. Segment addition postulate tells us we can add the two pieces to get the whole thing together. All right. questions there? So, segment addition postulate problems. Add the two smaller pieces. They have to equal the big piece, everything together. Midpoint problems, the two pieces have to be the same, have to be equal. So you're going to set them equal to each other. They're really the two basic ways that we're going to solve problems in this section. Okay. Homework. There we go. Link pass folder.